Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 950. Please turn to it, page 950, and today is our lesson number 137. Let's take a look at it. There are two problems here, number 7 and 8, and these are the last two multiple choice questions before they begin the graded questions on the next page. And because they are last of the series of 8 questions, these are hard questions on a scale of 1 to 8. On a scale of 1 to 8, these are 7 and 8. Let's take a look at it. Let's take a look at them rather. We are told that y is inversely proportional to x. Y is inversely proportional to x. Now listen, before we talk about what it means for two variables to be inversely proportional, let's first talk about what it means for two variables to be directly proportional. This is something that we have already talked about many times before. Well, not many times, but I remember it distinctly at least a couple of times when we ran into similar problem in the previous exams. And we're going to do it one more time. What does it mean for two variables to be directly proportional? For example, here we have A and B. 1, 2, 3, 4, and 5, let's say. When A is 1, B equals 3. When A is 2, B equals 6. When A is 3, B equals 9. When A is 4, B equals 12. And when A is 5, B equals 15. As you can see here, as you can clearly see here, that every time the value of A goes up, the value of the variable B goes up as well. In a situation like this, we say that A and B are directly proportional. Sometimes, out of laziness, people leave out this word and they will simply say that A and B are proportional. What they should say, correctly speaking, strictly speaking, that is, they should say that A and B are directly proportional as opposed to just proportional. A and B are directly proportional here. X and Y are inversely proportional here. So let's talk about what it means for two variables to be inversely proportional and directly proportional. Now, it wouldn't have mattered here if I had said that A and B are directly proportional or B and A are directly proportional. It really doesn't matter. The point here is that directly proportional means that when one goes up, the other one goes up. When the one goes down, the other one goes down. In other words, directly proportional simply means, or proportional simply means, that they move in the same direction. Whereas inversely proportional means when one goes up, the other one goes down. And when one goes down, the other one goes up. They move in the opposite directions. If they move in the opposite directions, they're said to be inversely proportional. The question here is, how do we express this thing in terms of equation? Let's do it here. I changed my mind. I'm going to use this space here because I need the room. As you can clearly see, the relationship that we have here is pretty straightforward and very simple to decipher because it's a very simple relationship. We can see that B always equals 3 times A. 3 times A, as you can see, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is so on and so forth. This 3 that we see here is called the proportionality. Let's put it in a capital letter. Is called the proportionality constant. And the way we came up with the 3 here, the value of 3, just like that, we just came up with this because, as I said, it's a very simple relationship. We can see that it's 3 times the amount. Sometimes that relationship between the two variables is not that clear, and we have to do some work to figure it out. So now we're going to discuss the actual procedure that lies behind it that will enable us to come up with this 3. And this is how we do it. Okay, here's the process. This is how we write it. A, B and A are directly proportional. This is how I would say B is directly proportional to A. This is how we write it. And then this means that B must equal some constant times A. Some constant we already know is 3. Some constant times A. The question is, how do we find the value of that constant? Well, it's very simple. By taking any one of these observations, we can find the value of k. Any observation. For example, when a is 4, b is 12. When a is 3, b is 9. So when a is 3, b is 9. Which means 3 times k equals 9, which means if we divide both sides by 3, k must equal 3. Which is exactly what we found here. K equals 3. This is called the proportionality constant. In order for us to answer this question number 7, we have to we have to understand and we have to know how to calculate, how to decipher the proportionality constant that exists between x and y when they are inversely proportional. You have to read carefully. It says x and y are inversely proportional. So now we're going to learn the procedure when the two variables are inversely proportional, right here on this side. When the two variables are inversely, again, when they're directly proportional, we say that b is directly proportional to a, which means b equals some constant k times a. That constant is called, this constant is called the proportionality constant. Which in our case is 3, as we saw there, because we realize that b equals 3 times a. So proportionality constant is 3 here. When the two variables are inversely proportional, we will say that if y is inversely proportional to x, y is inversely proportional to x. Now listen, I could very easily just stand here and to solve the problem and be done with it in a minute, but you won't get much out of it. We're not here to solve problem, we are here to learn the concept. There's a big difference between the two. I want you to learn the concept so that you understand it and you're able to apply it next time when you come across a similar problem. So y is inversely proportional to x. How do we express this? This is how we do it. Y, we say, is inversely proportional to x. Since this inversely proportional is going to be 1 over x. That's how we express the notion that when one goes up, the other one goes down. For example, when x goes up, the y will go down. If x happens to be 2, this will be half. When x happens to be 10, this is going to be 1/10, and so on and so forth. When x goes up, the value of the y is going to go down, and here lies the constant. We have to find that constant. Let's do it. So we will write this as y equals some constant k times 1 over x. Keep in mind that this k, of course, is different from that k. These two have nothing to do with each other. It's an entirely different problem, which is why I use different symbols. Again, same as before, we need to have an observation where we can figure out the value of, where we know the value of x for a given value of y, or value of for a value of y for a given value of x. We need to find that pair in order to figure out this k. And they give us that pair. They tell us in the problem that y equals 15 when x is 5. We are told that y equals 15 when x is 5. So we're going to use that here. Y equals 15 times k times 1 over x, which we know is 5. Voila. Multiply both sides by 5. And here it is. This is our constant. Our proportionality constant. Our proportionality constant for this particular scenario is 75. The rest is downhill. All you have to do now, once we have the proportionality constant, we will have our equation. So our equation is y equals 75 times 1 over x. All we have to do is plug in the value of one of those variable, x or y, and figure out the other one. Let's do it on this side. So now the question is, when x is equal to 25, what is the value of y? So our equation k equals 75, we put it in here, k equals 75, so y equals k times 1 over x, and we know k is 75, so 75 times 1 over x equals y, and we are told that x equals 25. When x equals 25, y is going to be 75 times 1 over 25, therefore y is equal to 3. 1. That is how we do it. That is how it's done. And that's about it. But there is no easy way out of it, which is why it's a hard question. We have to know how to calculate the proportionality constant. Let's do number 8, shall we? We are done with this one. Number 8 is the next one that we're going to do, the last one. Number 8, I do not know why it's a number 8. I do not know why it's classified as a hard question. It's actually a very straightforward question. We are told that 2x plus z equals 2y. We are also told that 2x plus 2y equals 20. And the question is, what's the value of y? How much is y? How much is y? Somehow we can get rid of y for x from here. We can figure it out. So somehow we have to figure out what 2x is equal to, and that's right here. That's right here. 2x from here, we can tell, subtract z from both sides. So if we subtract z from both sides and z from the other side, we find that 2x equals, z is going to cancel out, is equals 2y minus z. 2y minus z. Now that is not helping us anywhere. That is not helping us. Did I write something wrong? 2x. Yes, I made a mistake. Let me start again from scratch. We are told that 2x plus z equals 2y, and we are being told that 2x plus 2y plus z equals 20. Now that makes our life easier. That makes our life actually very easy, because here we see 2x and here we see a z, and we know what 2x plus z is. 2x plus, so we can write this as 2x plus z plus 2y equals 20. So 2x plus z we know equals 2y. Put it in here. And we have 4y is equal to 20. Divide both sides by 4. And we get y equals to 5. That's it. Y equals to 5, and the answer is A. I wasn't paying attention a little while ago. That's it. Tomorrow we'll do the grading questions. Okay? I'll see you then. Bye now.